Most of us have fallen victim to that, made plans only to have them ruined by faulty weather forecasts. Even with today's advanced technology that allows us to travel to space, we cannot even accurately predict the weather on a bi-weekly basis. So what hope do we have in trending long-term climate patterns, say over 100 years? Within Earth's climate system, there are many variables that we are not able to accurately predict. We will briefly examine 3 of those variables, the first of which is the Nino-Southern Oscillation, called INSO for short. INSO is governed by the interactions between the eastern equatorial Pacific Ocean and the trade winds, a prevailing pattern of winds that normally blow westward across the equatorial Pacific. If the trade winds weaken or strengthen, it causes an El Niño or La Niña effect, respectively. Even though INSO is a function of the equatorial Pacific Ocean, its impact on weather patterns are global. This graphic illustrates how the El Niño and La Niña phases of INSO can have a great impact on Earth's global weather patterns. We have a good understanding of how INSO affects Earth's global weather patterns. Unfortunately, the best our current prediction models can do is predict either an El Niño phase or La Niña phase at a 6-month to 1-year lead time. The next variable in Earth's climate system that we will examine is the Sun. We like to think of the Sun as just a happy little disk in the sky that's incredibly stable, but the truth is more scary than that. The Sun is actually in constant flux, and it follows approximately 11-year cycles of intensity. The problem is that we cannot always accurately predict these 11-year cycles. Proxy data even suggests that the little ice age was caused by an extended period of low solar intensity. The final and most unpredictable variable in Earth's climate system that we will explore is human activity. Few scientists argue against human-induced global warming, but what is still argued is the rate at which that warming has happened and the rate at which it will continue to happen. This graphic, courtesy of NASA, illustrates a rise in average global temperatures following the Industrial Revolution. We humans are perhaps the most powerful variable in Earth's climate system because we have both the power to work in spite of the environment or to work with the environment. Traditional cityscapes are a perfect example of working in spite of the environment. The following, courtesy of the San Antonio River Authority, is an example of humans working with the environment.
So weir is a dam where water flows over the top instead of going underneath or around a spillway or something like that. And they're used for grade control, to hold water up at a certain level. And we had a lot of those on the San Antonio River after channelization. Because we removed, remember we removed all those bends, and so if we once had a 2-mile long river segment over 1 mile length, and we changed that to maybe a 1.5 mile segment, we left the same elevation drop, but we shortened the distance. So what does that do to the slope?
This increases the slope and imparts more speed on the water.
Faster water, what does that do for your erosive capacity? Yeah, it makes it much increase. So the way to alter that is to put in these grade control structures like weirs, where you impound water behind it, slow that water down, then all that energy is dropped, so it dissipates very rapidly. So what we're trying to do now is still have that same function, but make it more ecologically viable. So what you see here is we still have that kind of weir structure, but instead of there being just a vertical drop, we run it over this riffle, these large rocks, But what's happening is every time you see the little bubbles pop up when water's going over the rocks or between the rocks, that's adding dissolved oxygen back into the water, okay? Dissolved oxygen is what fish need to survive. It also allows a lot of the bacteria, microbes, and things like that. It allows them to start pulling out some of the nutrients and metabolizing some of these other things in the water. So it's a great water quality benefit on several different levels. Also,
in summary, each of these variables can cause significant local deviations from a long-term 100-year temperature trend.